Good morning, students. As you can see, I am not here today. So I'm going to go ahead and we're going to go through lesson 611 through a video. So we're looking at how do these compare. This is going to be some of the introductory ideas to what we've been doing with solving equations. So you should have gone through these problems here with your team already, and then watching the video to kind of help you go through it. All right, so how do these compare? We're going to compare expressions. In chapter 4, you worked with writing and simplifying expressions. As you wrote expressions, you learned that it was helpful to simplify them by combining like terms and removing zeros. In this lesson, you and your teammates will use a tool for comparing expressions. The tool will allow you to determine whether one expression is greater than the other, or if they are equivalent ways of writing the same thing, that is, if they are equal. Remember that to represent expressions with algebra tiles, you will need to be very careful about how positives and negatives are distinguished. To help you understand the diagrams in the text, the legend at the right will be placed on every page containing a mat. It shows that the shading are for positive ones and the non-shaded are for negative ones. Also, when you have a positive one and a negative one, that represents a zero pair. That's going to be very valuable as you go through and simplify each of these. So we take a look at our first one. Ignacio and Oliver were playing a game. Each of them grabbed a handful of algebra tiles and they wanted to see which expression had a greater value. So the two expressions can be compared by dividing the expression mat into half to change it into an expression comparison mat. That's what we have here in the top right. Then the two expressions can be built side by side and compared to see which one is greater. So Oliver put his tiles on mat A in the picture and is described as 5 plus negative 3. Ignacio put his tiles on mat B and said it was negative 5 plus 2. So with your team, you were to have just figured out how to compare which one was greater. So this is one of those that lends towards a zero pair idea. And if you do the math here, so if you just did 5 plus negative 3, you should end up here. Oh, sorry about that. I forgot to put on my pen. All right, additive 5 plus negative 3, you should have found that equals 2, and negative 5 plus 2, that equals negative 3. So just taking a look here, you can tell that mat A or Oliver's here is greater. The way that you can use the mat to show that is you want to look at the idea of zero pairs. So look for a positive one and a negative one that compare with that can combine with each other. So we have 3 negatives down here, and we can partner those with 3 positives. And what I circled then would no longer be part of mat A. And as you can see what's left, there are 2 positives. Same idea on mat B. We have the 2 positives here that we can zero pair up with 2 negatives. So those are no longer a part of that mat either. So when you're looking at this, act like none of those are there and none of those are there because they made 0. We don't have to use them in our comparison anymore. And we're left with 2 positives in mat A for Oliver and 3 negatives in mat B for Ignacio. So which mat is greater? Mat A is greater. So this one utilized that zero pair idea because 2 is greater than negative 3. That would be y. All right. So our second one, we have 2 expressions built here, and we're going to be figuring out which one's greater. Is mat A or mat B greater? This one's going to utilize a little bit different of a strategy. It will still utilize zero pairs, but it'll also use the idea that there's the same thing on mat A as there is the same thing on mat B. And really we're using kind of a subtraction idea of what we've done with our 1-step and 2-step equations here to help us solve. So if you look at mat A here, you have the x squared and the x squared are the same. They're on the same side of a scale if you think about it. They're on the same side of an equation. So what you have to do is you have to remove those. So that x squared and that x squared, if they are both removed, then that keeps the equation balanced. We removed x squared from each side. Then let's take a look at the x's. Well, we have the same thing on both sides, so you could use a couple different strategies here. You could either do what we did with the x squareds and remove each of them from the sides, or you can recognize that we have a positive x and a negative x, and those make a 0, and those make a 0 here. So those both are 0 pairs, and they go ahead and are eliminated from that. So far, we've gotten rid of our x squareds. Those are gone. And we've gotten rid of each of the x's here with this one because they make a 0 pair. All right, now we look at, well, we have -5 tiles, -5 1 tiles on mat A and -4 1 tiles on mat B. So here let's use what we did for the x squareds. We have same things on both sides of the equation mat, so we can go ahead and remove those. So on our right side here, we have 4 -1 tiles. And on our left side, we have 5, so we can take 4 of them, like I circled, and those can get removed from ours because they are balancing each other out. If we remove the equal amount, then they will work out. So we can, those are eliminated on the mat A, those are eliminated on mat B. So right now we have a value of -1 on mat A because that's all we have left. And on mat B, we had nothing left. So that has a value of 0. And ultimately, then you're going to compare. Is -1 less than or greater than 0? And -1 is less than 0. So that would mean that mat B here is greater. Mat B is greater for this one as a result. So we reviewed a couple different ways here to do it. We looked, and when we had the same thing on each side of the mat, you're able to remove, as long as you remove an equal amount of them, that's going to be equivalent. That'll keep it balanced. That's the idea of when you have like 2x plus 5 equals 8, we subtract 5 from each side. And that is what we're doing here. We subtracted the x squares from each side. We subtracted the -4s at the bottom from each side. So using that strategy. All right, then you would go ahead and take a look at the next one. So 6-3 here. Trying to figure out which one is greater here. All right. So first things, when you have this, we kind of got a mix of things going on. They're not quite as organized as they were before. But what I like to look for personally first is I like to look for 0 pairs. And what kind of 0 pairs can I make so I don't even have to worry about those? So if I look at mat A, I only have the one x, so I have nothing to 0 pair with it. If I look at my integer tiles here of the positive 1s and negative 1s, I can make 1 0 pair here. I can take one of the positive 1s and partner it with a 1 -1. So those are gone. Those made a 0 pair. Same thing on mat B, take a look. I can't match anything with the x. So I can make a 0 pair with 2 of those positive tiles and 2 of the negative tiles. So now those are all gone off of my mat B here. So I made some 0 pairs there. All right, now I can start looking at the left and the right. What do I have that's the same that I can go ahead and get rid of? So I have this x tile that's on the left, this positive x tile, and a positive x tile on the right. Those can go ahead and those can be taken out. Because I'm taking out the positive x tile on one side and a positive x tile on the other side, that keeps my mats balanced from what I'm doing so far. All right, and then from there, we look for our integer tiles to see what do we have here. Well, you can see clearly mat A has more than mat B for integer tiles. So if we look at how many does mat B have, well, we have the 2 here at the top that we can take away with 2 from the left side. So those get taken out from each side. And we analyze what is left. So I'm just going to scribble out what have we gotten rid of here. We've gotten rid of those x tiles as well. We got rid of the 2 positive tiles. So we're left with mat A has 4. So 1, 2, 3, 4 positive integer tiles. and mat B has 0. So we take a look, well, which one is greater? 4 is greater than 0, therefore mat A is greater than mat B. So here, mat A is greater for this one as well. So hopefully that is making sense what we're doing. That's what they're calling when they talk about the legal moves. So the two different legal moves that they're talking about, those are the 0 pairs, and those are the removing from both sides when they're the same thing. So this is what they talk about with that. Two kinds of legal moves that we talked about. So removing balanced sets, that's removing the X from each side. Then the removing zeros, that's that 0 pairs that you make within your own mat. So that's the difference. The removing balanced sets, that's going to come from both mats as you're going through it. You're going to remove from mat A and mat B at the same time, and they have to be removing the same thing. Removing zeros, that is going to happen on its same mat. So mat B here has the 0 pairs. So those are what's going to get combined. So here, when you remove balanced sets, think about this as when we're solving, it's the inverse operations or those opposite operations that we did. When we start to do this with just our equations like we did with the 1-step and 2-step equations so far, that's going to be what we talked about when we did those inverse or opposite operations to simplify. Removing zeros, this is going to be the idea of combining like terms. So we have done that. We did that in chapter 4. We did combining like terms. That's what the 0 pairs are. 0 pairs are really your combining like terms is what you're doing. Because if you think about, so I'm just going to go with mat A here to show you in number terms. This would be 7 plus a negative 1. And mat B here would have been 4 plus a negative 2. All right, so we make those 0 pairs on this left side here. That 1 and negative 1, those make a 0 pair. And really what you're thinking about is you take one of that 7, so 6 plus 1 plus negative 1, and here's that 0 pair right there. All we did was break down that 6 and that 7 into 6 plus 1, so we're left with here just 6. Same idea here on the right, if we break down that 4 to 2 plus 2 to help show you where those 0 pairs are coming from. Here, that 2 plus negative 2, that's our 0 pair. So we're just left with 2. And this is where it's actually happening mathematically. This is what we're doing mathematically here. If I show you on the left side one, let's see, so we have x plus, what is that, 7 of them, and plus the negative 1. I'm going to show you how we get rid of those x's. So I'm going to put an equal sign here right now, just to show you. X plus 4 plus negative 2. So what we're doing by taking those x's out of each side, mathematically, really what you're doing is you're subtracting x from each side. And when I subtract x from each side, that makes that 0. And that ends up making that 0 on this side. And that's how we are eliminating those. That's how we're mathematically eliminating those, is we're really subtracting x from each side. We're keeping that equation balanced by doing it, what we do to the left side, we do to the right side. So, all right. And then lastly here, your mat A and mat B for 6, 5. If we take a look at these, ultimately you should go ahead and look for those 0 pairs and look for what can I do to remove from one side to the other. So let's start with mat A here. We have a 0 pair here with the x, positive x and negative x. So those are all gone. And then we have 3 negatives that we can partner here with 3 positives. All right, so that takes care of 0 pairs on mat A. Then from there, let's take a look at mat B. I have nothing to combine with that x, but I do have 3 positive and 3 negative tiles that I can go ahead and zero pair. So those are taken care of. All right, now I have to compare left to right. I have to compare mat A to mat B and see what do I have that's the same that I can get rid of. So on mat A, I have here, let me change the color just because it's a little small. I have this X tile here in the middle, and I can partner it with that X tile on mat B, and those are going to get taken out because they're the same. And then lastly, change color one more time. Let's go with green. Now I look at my positive 1 tiles here. On mat A, I have 2 of them, and on mat B, I can partner that with 2 of them, and those are gone, and those are gone. So scribble that out. Those are all zeroed out. Same thing, I got rid of those X tiles. And I'm left with, on mat A, I just have 0. There's nothing left. And on mat B, I have 1. So 0 is less than 1, therefore mat B is greater. Mat B is greater. And then ultimately, as you went through, I wanted you to go through problem B. I will tell you that ultimately, as you went through problem B, you should have ended up with mat A being greater for that one. So when you went through and you made your 0 pairs, you combined the left and the right, you should have ended up with mat A being greater. So hopefully this helps. We will review some of what we talked about here today on Monday when I'm back. So ultimately, that is where we're at. I did not have you do problem C and D. So you have the remainder of class here for your assignment, problems 6 through 11. And once you have completed that, I would like for you to work on some Freckle or Prodigy or read, something to be nice to the rest of the students. So thank you and have yourself a great rest of your Friday and your weekend.